We're staying in here.
Okay, so I want to take a look at a couple of these problems these are from 8.6. Now, if we're going to solve for x here, what can we do? What's some ideas? What can we do? Okay, we could separate the two triangles for one thing. We could separate, let's make the big one, we'll just make that the blue triangle, how about? And if I pull that little one out there, it's kind of like that, right? Now, what are the dimensions then if we do that? Well, this whole thing, it looks like, is 30, right? What's the whole base going to be? 2x plus 6, x plus x plus 6. So, okay, so there are the right side and the base of the big triangle. Now, the red triangle is similar. What would its dimensions be? What would the base be? And what's its? 21. Good. If this is 9, 9 is just this distance right there, isn't it? So we got to subtract the 9 from the 30 and get 21. There we go. Now, what would the ratio be that we could set up here to solve for x? If we do ratios of corresponding sides, what do you think, Mr. Rickman?
30 over 21.
Okay.
Equals
Good.
2x plus 6 over x plus 6.
Good. Okay, so we'll go big to small, right? And the right side of the big triangle is 30. The right side of the small triangle is 21. And then base of the big triangle, 2x plus 6. Base of the small triangle, x plus 6. We always want to reduce those if we can. That one reduces. 30 over 21 reduces to what? What's a number I could divide into both the top and the bottom? Okay, good. I could divide top and bottom by 3, couldn't I? So I could write that as 10/7. And then all I'd have to do is just cross multiply and solve for x, right? So if we do that, if we cross multiply, we're going to get 10 times the quantity x plus 6 equals 7 times the quantity 2x plus 6, right? Now what? Distribute. 10x plus 60 equals 14x plus 42. Which side should we pull the x's to? Right? How many would I end up with on the right? Good. Let's subtract 10x from both sides. So the numbers go the other way. What's the number on the other side? 18. 40 minus, or 60 minus 42. Divide both sides by 4. And we get x equals 18/4, which reduces to 9 over 2. Very good. Okay, good. That works. Everybody see that? So we got two similar triangles. We can separate those and set up ratios of corresponding parts. That works great. Okay, there's another little trick we could do here. Might even make it easier. Anybody see another way we could do this one? Without having to use similar triangles? Can we use one of those relationships from 8.6? What do we know about, in order to see this one, I guess, if these two angles are both congruent, what's that tell us about those two segments? Parallel. They're parallel. So if those are parallel, now what? What's happening? Remember, if we have a line that cuts through a triangle parallel to one side, remember what it does? It's going to cut those sides into proportional segments, right? So we could say, for example, for the top line, left over right would equal for the bottom line, left over right, bottom side, I should say, right? Does that make sense? Okay, that's just a little bit easier to deal with, isn't it? So then if we do that, we end up with, what are our ratios? So what's the length of that segment? 9 over, no, 21. Good, that part's just 21, isn't it? 9 over 21 equals, okay, maybe a little bit easier. And then 9/21 would reduce to what?
3/7.
3/7. Okay, good. So we could, maybe a little bit easier. I don't know, not a ton, but maybe a tiny bit. Make sense? Okay. What about that one? Now this is, the key here, we haven't done a lot like this. These angles are congruent, right? So this segment is bisecting one angle of a triangle. What does that do? How can we set up our ratio equation here? If this segment bisects the angle in the triangle, what's one way I could set this up? Okay, I can say 3 over 4 equals 7 over x. That works. You may see a different way? Yes, ma'am.
Well, and then, like, because both up two sides together with the 7, well, like the 7 and the 4 and 7. So would it be equilateral?
Equilateral, which you mean this one? Oh, 7, 7, and in this case?
Yeah.
Maybe this one is, but actually it's not. But even if it were, that's not in general going to happen. It's just an accident that those two numbers add up to 7. So don't. You saw an interesting relationship there, but don't generalize that because it's not always going to be that way. It's just sort of a, freaky thing here. It's not normal though. Okay, but it's a good eye. I mean, you saw something interesting there. Okay, what's another way we can set up this relationship? Do we see a different way? I bet you can just use your intuition. It'll tell you. 4 over x would equal 3 over 7. That's going to work too. Sure. And then I just cross multiply and solve for x, right? No big deal. Okay. Oh, hang on a second. Did I get there? Yeah, that's right. Yep. Okay. What about that one? Now there's a potential pitfall here. You got to really take this one carefully, or it looks like it could be hard. What's the 8.6 relationship I can use to set up this ratio? Okay, good. Now we know here this is just like that one, isn't it? Where I've got these two parallel lines, and this line's cutting through a triangle. It's just like that version. If these two lines didn't actually meet at a point, if instead there were another parallel line there, it's the same relationship. Okay, they go together in 8.6. So we know that if 3 parallel lines cut through 2 transversals, then they're going to cut up those transversals into proportional segments. So we can once again say left over right equals left over right. Okay? So then the ratio looks like, as was suggested, 3x over 5x equals what? Okay, now if we just go straight into cross multiplying, we get x squareds in there, which we don't really want to deal with, but we can possibly avoid it, and we can. How could we avoid having to cross multiply and end up getting x times x for x squared? What do we always want to do to these ratios if we can? How could we want to simplify or reduce them, right? Now, what about the left one? What can I do to simplify that one? Get rid of the x's, because if I divide x by x, they cancel, don't they? Right. So in this first one, I could cross the x's out, and that just gives me a plain old 3/5. Makes sense, doesn't it? 3x over 5x is still in that ratio of 3 to 5, right? What about the other one? I'm stuck with that x on the bottom, aren't I? Because that can't cancel. But what about the 60 over 8? Does that reduce? Can I divide both of those by a number? What? 4, yeah. 4 goes into 60 15 times, and it goes into 8 twice. Okay, now it's not so bad, is it? Now I can just cross multiply and solve for x, right? No big deal. Do we want to do it, or just, I'll leave that up to you guys. You guys can do that. But this is the part we want to get this relationship set up, right? Okay, questions? Okay. What about these? We looked at it. I know we looked at this a little bit, but let's take another look. What if we want to find AG? So this distance right here is x. Suggestions how I could do that? Yes, sir. Yeah. Absolutely. There's probably the easiest way. Now I could, if I wanted to, I could set up similar triangles. I could take the little triangle and pull that one out, and then this medium-sized triangle and pull that one out, and they'd be similar. That would work too. But this is much easier. Once again, we got 2 parallel lines, right? And this triangle. So I know that I can set up this line right here, which is parallel to one side of the triangle. And maybe it even helps. Why don't I do this? Let's just get rid of all that. I wouldn't even need that stuff down there. Okay, we can just get rid of that bottom one. That's all we need is that part, isn't it? Right, if I have a line that's parallel to one side of a triangle, then it's going to cut the other 2 sides proportional. So we could just say x over 6 equals 3 over 4. Right? Make sense? Okay, good. Now what if we were actually trying to find AE, let's say, instead? Then I'd have to get this other little piece down there. How could I get that piece? Okay, I'm hearing some good stuff. And I'll move that up there so that he's out of the way. What if I were just trying to find that one there and it were y? What's the ratio I could use there? Ah, good. 6 over y equals 4 over 3. Very good. Okay, good. What if, instead, what if I were trying to find maybe this guy? How can I do that? Okay, we're seeing similar triangles, aren't we? Here we could take the big triangle and the little triangle, which are similar, aren't they? For the little triangle, I've got side lengths of 3 and 2. For the big triangle, what's that whole side length there? 10 and x. So I can take the ratios of corresponding parts. So I could say small to big, 2 over x equals small to big. Right? Okay. Are we getting that stuff? Okay. Okay, on to 8.7. What about this? Now, building casts a shadow that is 42 feet in length. The yardstick casts a shadow that is 4.1 feet in length. How tall is the building? This stuff is useful. You could use this if you wanted to measure the height of a really tall tree. You know, you can't do it directly because you can't. You know, if it's really, you can't climb clear up to the top of the tree and break off, right? And I mean, it's hard to get a tape measure up to the top of that thing. But you could pretty easily measure the height by doing something like this, right? So we need a picture. So here's our building, let's say, and there's the sunlight that's passing by the edge of the building, right? So how tall is the building? That's what we're looking for. So that's x. What's the length of the shadow? 42. Okay, that's a right triangle, right?
If you do 42 to 1.1 equals
Yeah. Yeah, you're right. And how come? Because here's the yardstick. right? If the yardstick is perpendicular to the ground, then wouldn't you agree here, kind of the tricky part of this is, the sun is so far away that the light all comes in parallel, doesn't it? Right? I mean, so isn't this angle the same as that angle? Right? So then those are similar triangles, aren't they? Right? So good. So now if we label these parts here, what's the height of a yardstick in feet? 3. And if the shadow is 4.1, then we've got corresponding parts. So we could say, for example, big to small is same thing as saying x over 3 or 42 over 4.1, sure. Okay. Right. Now, what if we wanted to find a scale factor between those two? I want to find a scale factor between those two triangles. Let's say that we're going to call this the starting and this the ending. How could I come up with a scale factor? What's a scale factor mean? Yeah, it's a ratio that describes how much bigger or smaller is the final shape than the original, right? So I could just take the ratio of corresponding sides. And what about these two right here? Isn't that a corresponding, those two are corresponding sides, right? Okay, so if I set up that ratio then, I'm going to get 4.1 over 42. That's a pretty small number, right? So that makes sense. Less than 1, sorry, because it describes a reduction. We're going to multiply all these measurements by this small number to get the reduced measurements, right? Okay, but if I put that in Moodle, if this were a question in Moodle, and it said, what is the scale factor? And it does something like this. It has a box, right? Remember those? Okay, now if I put in 4.1 and 42, am I going to get it right? How come? What's not quite right about that? What doesn't look good about that fraction? Decimal. We don't want to have a decimal fraction, right? The fraction needs to have integers. So how do I take this fraction and get rid of that decimal? Yes, ma'am? Yeah, multiply the top and the bottom by 10. What that does is it moves the decimal place 1 to the right, doesn't it? So then I end up with 41 over 420. That's what we want. Okay? Now sometimes once I get there I can reduce that fraction, but here I can't. I think I think that's it. Okay? Make sense? Okay? All right. What about this? These look kind of confusing, but if you pause and just stare at that for a second, it's not that big a deal. Okay, is that dilation first of all, is it an enlargement or a reduction? Enlargement. How come? Okay, good. Because the prime version is the bigger version, right? You always start, the prime always means the changed, or the final one, right? Prime means after you've done something to it. So P prime is in the bigger of the two, so it's an enlargement. Now, what if I knew, I don't, but what if I knew, for example, that the length of this side was 5 and the length of this side was 3? What would the scale factor be? Okay, I'm hearing 5/3 and I'm hearing 3/5. Which one's right? Or are they both right? 5/3 has to be. Good. Because it's an enlargement, right? We always do the final version on the top. Whoops. The final version on the top and the original version on the bottom. Okay? And you can always check yourself. Is that bigger than 1? Yes, it is. So does that correspond to an enlargement? Yes, it does. Okay? Now, we don't have that information, though. We don't have any of the lengths of the corresponding sides. So how can we come up with the scale factor here? 12 over 8. Yeah. Now, how come? What's that mean? This is the part that I bet was a little confusing to you. if this is the center of the dilation, then all the points on the plane, when we dilate everything, are going to either move away from or towards the center by corresponding amounts, proportional amounts. Now, here's the best way I can think of to think about this. You have to use your imagination. You're looking through a camera lens with a zoom on it. As I zoom in, things get closer, right? See, I'm zooming in on a bird's nest a long ways away. Now, tell me what happens in the very center of the lens when you zoom in. If I zoom in, it's going to get bigger. But let's say I'm focused right on a little.
Stays the same.
It stays the same, right? If I'm focused on an egg in that bird's nest and there's a little mark on the egg that's in the exact center of the frame, isn't that going to stay put when I zoom in? Everything else will change around it, but it'll stay in the exact center, right? Now, what's going to happen to the other stuff in the picture? It's going to move out. As I zoom in, it's going to kind of migrate off the screen, right?
Yeah.
Things that start out, and you could even tell me how much. Like something, let's say I was focusing right there, and then this point's going to move by that much, let's say. A point that was further away would have moved out even more. In fact, they're going to move by corresponding amounts, by proportional amounts. If I focus in enough that a point that in the original picture was right here, if I focus into, I twist the zoom lens until that is moved twice as far away from the center of the screen or the picture, every point on there will have done the same thing. Points that were closer are still going to double their distance, right? But that won't be as much because the distances are smaller. Spots that were further away in the camera will have increased the distance even more, maybe even going off the screen, right? Now, what if I zoom out? I twist the lens the other way. The point in the center still stays there. What do all the other images do? All the other parts of the image do as they zoom out? They're going to move inward towards that center, right? Does that kind of make sense now with the center geometry? That's what we're talking about. When we talk about the center of a dilation, just think of that as being the focus point of that lens, right in the very center of the picture frame when you're zooming in and out, okay? So then we also know that the dilation is the ratio of how far points migrate when you focus in or focus out, when you dilate the image, okay? So then does it make sense that we could say that the scale factor is also, we could write it as 12 over 8, right? Make sense? What's that reduced to? 3 over 2. So if I want to solve for x, how could I set that ratio? Could I set an x into that equation? Say it again. What is it? X over 3. Good. Because we got big over small equals big over small, right? And there's a pretty simple equation I could solve to get x, right? Okay. The same kind of thing is going on here. Is it a enlargement or a reduction? Reduction. Okay. What's the scale factor? 5 over 12. Okay. All right. So last one. This guy. Okay, I'm gonna make this. I'm gonna make this a little smaller. So I don't run off the screen. Okay, now look what we're doing here. This one, okay, this one is dilated about the point 2.6. This is not real convenient. That's off the screen. But if I keep going up, okay, the center, 2.6, so that's over 2 and up 2, 4, 6 is right about there. There's the center. Right? So if I'm going to dilate that where the scale factor is 5/2. Is that an enlargement or a reduction? An enlargement. So that's where we're focusing the camera is right there. Agreed? And then this whole thing is everything's going to get bigger, but as it gets bigger, it's going to move away from that center proportionally. Everybody agree? Okay. If we want to know where A prime, B prime, and C prime are going to end up, that's hard to tell because the camera is focused someplace that is not on the center, on the origin, right? Wouldn't it be easier if we were going to do this to move where the camera is focusing to the origin, then do our dilation, and then maybe shift the camera back? Right? We can do that geometrically. All we have to do is if I want the center to be there, what do I have to accomplish to do that? If the coordinates of the center are x equals 2, y equals 6, what do I have to do to those x and y coordinates to make them 0, 0? Okay, subtract 2 from the x coordinate, subtract 6 from the y coordinate, right? I can do that for all the points on the plane. Scoot the whole thing left 2 and down 6, right? So that it puts the center conveniently right there on the origin, right? Now if I do that, what's this thing going to look like? Okay, if I do that, if I move the center down to there, what's that going to do for each of these points? Well, B, for example, was at 1, 2, 3, 1, 2, 3. So where is, we'll call it B prime. Where's B prime going to end up then? If I subtract 2 from the x and 6 from the y. 1, negative 3. Okay, so we're going to go over 1, down 3. So there's, we'll call that B prime. Okay. Did I mess that up? Oh, positive 1. Whoops. You're right. So positive 1, negative 3. So right there. There's B prime, right? Where is C going to be? C starts off at 3, negative 1. So it's going to be at what, 1, negative 7? So there's C prime, right? And what about A? A was at negative 2, positive 2. So where does it end up? Negative 4, okay. And then negative 4? Is that right? Yeah, I guess so. Okay, so there's my new triangle after I shift it. Right? Makes sense? I've just taken the whole thing and just scooted it down there, right? Okay, now that I've got the center on the origin, dilating it is really simple. To make things a little easier here, how about if we make the dilation, instead of being 5/2, let's not do that. Let's just make k equal, how about 2? Okay, what does that mean? If the scale factor is 2, what is that going to do to each of these coordinates? Yeah, good. I'm going to multiply every one of those x and y coordinates by 2, right? So we'll end up then with, if I were to draw this is going to be really inconvenient, but we'd end up with, I'm going to go by 2's. 2. Well, actually, you know what I could even do? If I'm multiplying these all by 2, what if I just change these from 1's to 2's? That would work, wouldn't it?
Absolutely.
So this would be, that'd be like negative 2, negative 4, that's positive 2. And then each of these would become, that would become a 2, negative 6, right? This would become, what, 2, negative 14? And this would become negative 8, right? Okay. Okay, what's the last thing to do? Yeah, I gotta shift it back, right? Because remember, I moved the lens. So now I gotta take all these places, and I gotta scoot them all back up there. How far? Well, add 2 to the x coordinates, add 6 to the y coordinates. And so what would my final coordinates be? Call it a double prime. A double prime, instead of being -8, -8, if I add 2 to the x coordinate, I get, okay, if I add 6 to the y coordinate, I get, yeah, right? And b, whoops, b double prime would be 4, 0, right? And c, right, see that 0 can -6 plus 6? And then c double prime would be 4, and then -14 plus 6, -8. Make sense? Okay. All right, that's how we do that. Easiest way to do it. Okay, that's it.